Ever wondered if there's a computer that could outperform the most powerful supercomputers of today by leaps and bounds? Welcome to the world of quantum computing. This is a realm where science fiction meets reality, and the boundaries of what we thought possible are being redefined. Quantum computing is a fascinating field of computer science that takes the principles of quantum theory and applies them to computing. It's like putting on a pair of 3D glasses and seeing the world in a totally new dimension. This is a realm where subatomic particles, known as qubits, don't just exist in one state but can exist in multiple states simultaneously. Imagine if you could be in two places at once. How about 3 or 4? This is the magic of quantum theory. In the world of classical computing, we're limited by bits that can either be 0 or 1. But in quantum computing, a qubit can be both 0 and 1 at the same time, thanks to a property known as superposition. This means that quantum computers have the potential to process information at an exponentially faster rate than classical computers. But that's not all. Quantum computing also leverages another quantum phenomenon known as entanglement, which allows qubits that are miles apart to interact as if they were right next to each other. This is like having a conversation with someone on the other side of the world as if they were sitting right next to you. It's mind-blowing, isn't it? Beyond the wow factor, this technology has the potential to revolutionize industries, from security and finance to drug design and aerospace. The possibilities are as limitless as the states of a qubit. But of course, quantum computing is not without its challenges. So the big question is, will quantum computers redefine our future? Stick around to find out. In a world where speed matters, quantum computers are the Usain Bolts of the computing world. These super-fast machines are not just a figment of sci-fi imagination, but a reality that's quickly unfolding. Quantum computing is a fascinating field that merges the principles of quantum physics with computer science. It's like the secret sauce that has the potential to revolutionize how we solve complex problems. At the heart of a quantum computer are qubits, subatomic particles that can exist in multiple states at the same time. It's like having a superpower that allows them to process multiple solutions simultaneously, making them exponentially faster and more powerful than classical computers. Just imagine a problem that might take a classical computer thousands of years to solve, a quantum computer could potentially solve in just a couple of 100 seconds. It's like comparing a horse-drawn carriage to a rocket ship. The potential applications of quantum computing are vast and varied, from revolutionizing cybersecurity to speeding up drug discovery to advancing machine learning. It's no wonder then that some of the biggest names in tech, IBM, Microsoft, and Google, are investing heavily in this field. IBM even plans to have a 1,000-qubit quantum computer by 2023. These tech giants are not just dipping their toes in the quantum realm, they're diving headfirst into it. But it's not all smooth sailing in the quantum world. There are some significant hurdles to overcome. Imagine needing a computer to be as cold as outer space to function. Welcome to one of the many challenges of quantum computing. You see, quantum computers aren't your everyday laptops or desktops that you can just turn on and off at will. They are intricate machines that demand very specific conditions to work. Let's start with temperature. Quantum computers need to operate at incredibly low temperatures. We're talking colder than the vacuum of outer space. That's right. These computers need a chillier environment than what's found in the farthest reaches of the cosmos. But why, you may wonder? Well, it all comes down to the qubits, the fundamental units of quantum information. In order to maintain their multiple-state existence, or superposition as it's called, qubits need to be isolated from all external noise and interference. This means they need to be kept at temperatures close to absolute zero to prevent any heat-related disruptions. And it's not just about maintaining chilly conditions. Quantum computers also need protection from all sorts of interference, including electromagnetic and even cosmic rays. Yes, even particles from outer space can mess up the delicate workings of a quantum computer. Building these machines is no easy task either. It's a complex, time-consuming, and costly process. Think of it as building a skyscraper, but instead of concrete and steel, you're using subatomic particles. And you're not just battling gravity, but also the laws of quantum mechanics. It's a monumental task that requires the brightest minds, the most cutting-edge technology, and a lot of patience. Despite these challenges, some tech giants are racing to develop quantum computers. Who's leading the pack? Let's find out. In the tech world, it's all about who gets there first. Much like the space race of the mid-20th century, we're in the midst of a different kind of competition. This time, it's not about reaching the moon, but about mastery of the quantum realm. Google and IBM, two tech giants, are leading the charge. Each has ambitious plans for quantum computing, a technology that could revolutionize everything from drug design to machine learning. They're not just dreaming big, they're investing heavily to turn these dreams into reality. Google, for instance, has set its sights on having a fully operational quantum computer by 2029. Imagine that. In less than a decade, we could see a computer that uses the principles of quantum physics to solve complex problems faster than any existing supercomputer. It's like having a time machine that can leap into the future of problem solving. On the other hand, IBM is not far behind. They're not just aiming for a quantum computer, they're aiming for a 1,000-qubit quantum computer, and they aim to have it by 2023. That's right. A computer with 1,000 qubits, each capable of being in multiple states at once, exponentially increasing its processing power. But why this race? Why this rush to quantum supremacy? The answer lies in quantum computing's potential. This technology promises to outperform classical computers in many areas, from cryptography to complex simulations, making it a game changer for numerous industries. However, it's not just about who gets there first, but who gets there best. Developing a quantum computer is one thing, but making it reliable, affordable, and accessible is another challenge altogether. So, we've seen the potential and the challenges of quantum computing, but what does it mean for us? So, you're not a tech giant. Why should you care about quantum computing? Well, it's simple. The potential applications of quantum computing are vast and could touch every aspect of our lives, from the way we bank to the way we stay healthy. Let's start with security. In a world where data breaches are all too common, quantum computing could become a formidable ally. Thanks to the peculiarities of quantum physics, it can create codes that are virtually impossible to crack. It might sound like something out of a spy movie, but it's real, and it's happening. Now imagine for a moment that you're a financial analyst. Quantum computing could revolutionize your work by optimizing trading strategies, managing risk, and even predicting market trends. In fact, some say quantum computers could become the Wall Street whiz kids of the future. Quantum computing also has huge implications for the world of medicine. It could speed up the process of drug discovery and design, potentially saving millions of lives. Imagine a world where diseases like cancer can be tackled more efficiently, thanks to the power of quantum computing. And what about machine learning? Quantum computers could supercharge algorithms, making artificial intelligence even more intelligent. This could lead to breakthroughs in everything from self-driving cars to automated customer service. But it's not just about what quantum computing can do for us now. It's about the potential for future innovations that we can't even imagine yet. Just as the first computers paved the way for the internet, smartphones, and more, quantum computers could usher in a new era of technological advancements. Quantum computing may seem like a distant dream, but its potential impact on our lives is monumental. Stay tuned because the quantum future is closer than you think.